Start 4.2.2. We're going to use modeling to show how to multiply fractions. When you visualize the product of two whole numbers by drawing a rectangle with side lengths equal to a number, the area of the rectangle is represented by length times width, or 4 times 6 in this case. We can also use that to represent by fractions. We can cut them in half. Therefore, if you see that the diagram is 1/6, but half of each of the squares within there are shaded, that means we did 1/2 of the 6. So let's go ahead and fill out our foldable. The key for multiplying is the first thing is you do not find a common denominator. So we want to make sure we put do not at the top because you do not want to find a common denominator. What you want to do instead is you want to multiply the numerator by the numerator and multiply the denominator by the denominator. So it's basically top times top, bottom times bottom. And then you would simplify if possible. And most likely you will be simplifying when you multiply fractions. So let's think about it a little bit. What is the area of each of the small rectangles in the diagram above? Well, we can see that the whole diagram is 1/6, but we can also see that there is half shaded of each of those. So the area of each of the smaller ones would be 1/2. How many of the smaller ones are shaded? Well, all 6 of them have part of it shaded. So 6 of them would be shaded. Therefore, if we wanted to find the area of what is shaded, well, what is half of 6? That would be 3. That would be the area that is shaded. You could explain that by saying half of 6 is 3. If we wrote that as a problem with fractions, we would write 1/2 times 6, because that word of means to multiply. Let's look at another figure. Here, you can use similar diagrams to represent the product of two fractions. The shaded portion of this diagram represents the fraction 2/3 times 3/4. So what are the dimensions of the entire diagram? Well, we can see that the entire diagram says it's 1/1, but if we're looking at the squares, it's really 3/4. So you could write either 1/1 here for the whole diagram, or if you were counting the squares, you could say it is 3/4, depending on which way you're looking at it. Now look at the entire shaded region. What is the height of this reading? Remember, just what is shaded. Well, if you're looking at the height, we're looking at the shaded right here. So 2 of the height is shaded, so 2 out of the 3. And if we're looking at the width, we're looking right here, and we can see that 3 out of the 4 are shaded. So there, we can go ahead and write those down. To explain this, we're basically what I just said. If we're looking at the height and the width, looking at it as 3/4, 2 of the height are shaded and 3 of the width are shaded. So what is the area of the small rectangle, or the number of small rectangles? Well, 6 of the rectangles are shaded, but there's a total of 12 of them. So that means if I wanted to find, for E, to find my answer, I would be able to say, well, it's 6 out of 12, or simplify this to 1/2. So half of the blocks are shaded. Now let's go ahead and look at the diagram again and see if we can draw a couple diagrams. Once you get the hang of multiplication, you won't need diagrams anymore, but we'll use them for now. So first, let's say 1/2. So I'm going to divide my box in half because I need a half. Remember, we could say that it's 1/1, so we're going to divide it into half. And the top says we're going to divide it into 3, 1/3. So we're going to divide it into 3 sections going that way. Now, we want to determine what would our answer be. Well, if we went ahead and shaded 1/2 of it, so we can shade 1/2 going longwise, or the length, and then going up and down, we can shade 1/3 of it all the way. Do you see where the two colors come together and form a bright blue, that is actually our answer. So how many are actually overlapping or shading together? Well, only 1 out of the 6. So how could I write that as an equation? Well, if you look, the equation here is for us. So 1/2 times 1/3 equals 1/6. Let's look at the next one. It says 3 out of 5. Well, we have to divide it up into 5 sections. So let's go ahead and draw our lines for 5 sections across. And then we need 4 sections going up and down. We're looking at the denominator to know how many sections we need. Now let's go ahead and highlight what we need. Well, 3 out of the 5 going across will get highlighted. And 3 out of the 4 going up and down will be highlighted for our height. How many of them combined into the bright blue together to get that? Well, you can see that there are 9 of them that are combined out of a total of 20 blocks. So that means if I had to write my equation of 3/5 times 3/4, I would get an answer of 9/20. So go ahead and write out your equation. 3/5 times 3/4 equals 9/20. Let's look at the last one. Again, we're going to divide it in half because it's 1/2. Then we need to divide it into 6 parts. And your lines don't have to be perfect. Just make sure you get 6 of them in there. Mine are not perfect, but it's okay. Now we want to highlight a half going across and 5 going up and down all the way, because what we're looking for is what is combined, what is together, what's overlapping. So how many? Well, there's 5 of them out of a total of 12. And if we look, 1/2 times 5/6 equals 5/12. Remember, our rule was to multiply the numerators and multiply the denominators, and then simplify if possible. So now that we've looked at this, we can see that there are some shortcuts, what we just talked about. We don't necessarily have to draw the diagram. The box is there for you if you need to. But the shortcut is, and we can just rewrite it as top times top and bottom times bottom to get our answer. So top times top is 4 times 7 is 28. 3 times 7 is 21. Then we need to simplify. Well, in this case, I can divide them both by 7 to come up with 4/3, but we still don't want to leave it as an improper fraction. I want to go ahead and change that to a mixed number of 1 1/3. So remember, vocabulary words are important. So part of your vocabulary word is multiplying fraction by a fraction. That means you're going to multiply the numerators, multiply the denominators, and simplify it or turn into a mixed number if possible. Let's look at some more problems to try. In this case, we have 3/5 times 1/4. Well, 3 times 1 is 3, and 5 times 4 is 20. In this case, we can't simplify, so we're done. Look at number 8. 1/6 times 2/3. Well, 1 times 2 is 2, and 6 times 3 is 18. Well, in this case, I can simplify because I can divide them both by 2 and get 1/9. 4/5 times 5/8. Top times top. 4 times 5 is 20. 5 times 8 is 40. Now simplify. Well, I know that 20 is half of 40, so I can already see that this is going to be equal to 1/2. Number 10, 2 times 3 is 6. 3 times 7 is 21. Now can I simplify? Yep, I can divide them both by 3. Remember, whatever I do to the top, I must do to the bottom. 6 divided by 3 is 2. 21 divided by 3 is 7. You stop the video and try the last two. Come back and check to see if you got the same answers that I did. Welcome back. Hopefully these are the answers that you received by getting the multiplication down pat. Remember, top times top, bottom times bottom. If you're not sure, go ahead and give it another whirl. Draw a diagram if you have to, but double check. Let's look at number 13. Rob wants to create a small herb garden in his backyard. The space he marked off of the square is 7/8 of a meter on each side. What is the area of the herb garden? Well, if I took 7/8 away on each side, that really means 7/8 times 7/8. Because I took 7/8 away on one side and 7/8 away on the next side. Again, top times top, bottom times bottom. Let's go ahead and multiply them out. That becomes 49 over 64. Go ahead and check and see if I could simplify that. I would have to give it a chance to check. Remember, the numbers we want to check are 2, 3, 5, and 7, just to see if there's any way that we can simplify this. All right, give your homework a shot. See you in class.